We have explained previously the continuous time Fourier series and Fourier transform relationship for periodic signal. Now we turn our attention to the aperiodic signal. We can study the aperiodic signal by examining the situation where the period T0 becomes longer and longer, and when T0 becomes infinity, the periodic signal is the aperiodic signal. We will examine the examples using the periodic rectangle x of t in this figure. Comparing x of t in the top figure to the bottom figure, it is nothing but making T0 becoming larger and larger. What is the effect of T0? T0 is the fundamental period. It is related to the fundamental frequency omega naught, where omega naught is given by 2 pi over T0. As T0 becomes larger and larger, 2 pi over T0 becomes smaller and smaller. How would this affect our continuous time Fourier series representation? Remember that CK's, the coefficients of interest, are sitting at k omega naught. As omega naught becomes smaller and smaller, the spacing between the frequencies that are needed to reconstruct the signal narrows. At the limit, when T0 becomes infinity, the spacing between the harmonics required for reconstruction merges, and xj omega is now a continuum requiring all frequencies. Let us study this first remark. Is the remark we have just explained. Let us now put up CK, the continuous time Fourier series representation. The equations are here. Let us pay particular attention to k omega naught, knowing that omega naught will be affected as T0 increases. Comparing CK, the expression for the analysis equation, to the continuous time Fourier transform analysis equation, we see that integral of minus infinity to infinity of xt is exactly the same as the integral of one period of the periodic counterpart, because in the continuous time Fourier series, when we calculate CK, we are only integrating over one particular period. And if we observe that this integral of one period and compare it with the continuous time Fourier transform analysis, although it is from minus infinity to infinity, the values that is of interest is only identical or is the same as the top figure. And therefore we conclude that CK is equals to xj omega over T0. So this is the first relationship between continuous time Fourier transform and continuous time Fourier series. Simply to calculate x of j omega, we can calculate T0 multiplied by CK.